We're going to talk about powers and exponents in this video. Powers and exponents are two or more numbers that are multiplied together to form a product, and that's called a factor. When the same factor is used, you may use an exponent to simplify the notation. So what that means is when we're factoring something like the number 12, we're going to factor it into 1 and 12, 2 and 6, 2 and 3. Okay, so our factors of 12 are 1, 2, 2, and 3. All right, so this is a factor tree, if you remember. Now, if all these numbers that we use to factor were the same, for example, in the number 16, we can take 2 times 2 times 2 times 2 to get 16. If all of our factors are the same number, we can call this 2 to the power of 4 because we've multiplied 2 4 times. And this 4 here is called an exponent. It's the tiny number that's above your base, or the common factor. So the base of this is 2. It's the common factor that's been multiplied 4 times, so our exponent is then 4. That tells us how many times do we multiply the base to get the number. Okay? So numbers expressed using exponents are called powers. If I have 3 with an exponent of 2, that's 3 to the power of 2. That's telling me I would multiply 3 2 times. So 3 is my base, 2 is my exponent, and this is 3 to the power of 2. This is called a power. The whole thing together is called a power. All right, so if we have 5 to the power of 2, that's 5 to the second power, or we could also say that 5 squared. That's going to be 5 times 5, which will be 25. 4 to the third power, we call that 4 to the third power, or 4 cubed. That's going to be 4 times 4 times 4. 4 times 4 is 16, and then 16 times 4. Okay. Then we have 2 to the fourth power is shown here. We don't really have a special name for it. We usually just use squared and cubed for to the power of 2 and the power of 3. The power of 4 doesn't really have a special name, but that would be 2 times 2 times 2 times 2. And we know from up here in our example that 2 to the fourth power is 16. In this selection here where it says write each power as a product of the same factor, what it's asking you is to write out what you're going to multiply. So for example, 3 squared, my product of the same factor will be 3 times 3. I want you to go ahead and write out 5 to the fourth power as a product of the factors. And then in number 3, when m is cubed and when m equals 5, then how will I write that? So I'm going to replace the 5 for the m in my original little expression, and then write that out as a product of the same factor. For number 4, using the information that you've gotten in 1, 2, and 3, find out or evaluate or solve the power. So 3 squared then, if I go back up here, 3 times 3 is 9. 3 to the second power, or 3 squared, is 9. Go ahead and multiply out and find out the solution for 5 to the fourth power, and then m cubed if m is equal to 5. Comparing these now, when we come down here, we're going to actually multiply out and solve these exponents. We're going to evaluate it, they call it, evaluating the power. And then we're going to evaluate greater than, less than, or equal to between the two. All right, so for 2 to the fifth power, I'm going to multiply 2 5 times. So that's 2 times 2 times 2 times 2 times 2. I know that 2 to the fourth power up here was 16, so I just have to do 16 times 2, and that's 32. So this side will be 32. And then 5 squared is just 5 times 5, and that's 25. Now I know that 32 is greater than 25. So I'm going to put my greater than, less than sign in there. And you can complete that one. Okay, the rest of this is word problems, and it's going to give you the powers in here. So number 10, a certificate of pedigree lists a dog's parents, grandparents, and so on. The power of 2 to the 6th describes the number of great-great-great-great-grandparents a dog has. How many great-great-great-great-grandparents does a dog have? So we're going to have to evaluate the power of 2 to the 6th, okay? 2 to the 6th power. So that would be 2 multiplied 6 times. The exponent tells me how many times to multiply. So I'm going to take my number 2, my base of 2, and multiply it 6 times. 1, 2, 3, 4, 5, 6. On the previous page, previously in my notes, I just had 2 to the 5th down here. Now 2 to the 5th was 32. So I've got to multiply by 2 one more time to get 2 to the 6th. So 32 times 2 is going to be 64. So a dog has 64, I'm just going to put G's for it, great grandparents. Okay? All right. I want you to complete um, the rest of these. In number 11, write the number of squares that are on this checkerboard as a power. Okay? Write it as a power. So if it has 8 rows and 8 squares, what are you going to do to find out how many squares there are? And then you're going to write that as a power. What would I multiply 8 by? How many times do I have to multiply 8 together to figure out how many squares are on this checkerboard? Then evaluate that and tell me how many squares there are. So if we're doing length times width, that's going to be 8 times 8. So you tell me what power is 8 times 8, and then what is the answer to that power also. All right. Number 12 is finding area. Remember that area equals length times width. 13, which of these models represents 4 squared? So, or the square of 4 as it's written. So this is going to be 4 squared, okay? If you evaluated 4 squared, how many tiny squares would there be? And which one of these represents that? Okay. Every hour is cell divided into 2 cells. Which expression represents the number of cells after 5 hours? Okay, it doesn't give you any choices down here, so I want you to write an expression that will represent the number of cells after 5 hours. So you're going to have a base and an exponent for your answer here. Number 15, given that 2 to the 8th is equal to 256, describe how you would find the value of 2 to the 9th without multiplying 9 2's together. Okay, if you know that 2 to the 8th is 256, tell me what you're going to do to find 2 to the 9th without having to start at the beginning and multiply 2 9 times. All right, we'll see you tomorrow or next class period.